We're delighted to introduce our speaker today, Dr. Petra Wagner. Dr. Petra Wagner is Professor of Phonetics at the Center for Cognitive Interaction Technology at Bielefeld University, Germany. She leads the Bielefeld Phonetics Work Group. She won the 2018 Swedish Riksbanken's Humboldt Award for Outstanding German Researchers in the Humanities. Dr. Wagner's expertise spans phonetics, prosody, multimodal communication, speech synthesis and evaluation, and conversational speech analysis. Her current research interests are in applying speech technology for tackling fundamental questions within speech science, and using speech science to better evaluate existing speech technological application. Professor Wagner is the author and co-author of multiple publications, and to name just a few, she co-authored, just in 2022, Professor Wagner co-authored Laughter Entrainment in Dyadic Interactions, Temporal Distribution and Form, and that was published in Speech Communication Journal, and also How to Motivate with Speech Findings from Acoustic Phonetics and Pragmatics, that was published in Frontiers in Communication. And without further delay, Professor Wagner, the floor is yours, and we're looking forward to your presentation.
Thank you, Anna, for the kind introduction. It's a pleasure to be, well, not there, but that we can share this hour in Zoom. If you have any questions concerning terminology or, technical things that you might not be familiar with, because not all of you might be prosodists, and I am, so I might sometimes use terminology that you're unfamiliar with, please just shout and ask questions while I'm speaking, because sometimes I get carried away and I forget that not everybody is in the same field as myself. So please do not hesitate to ask questions if things are difficult to understand. Yeah, it's a great pleasure to talk about a study that is currently under review. And so we're hoping that we get it published soonish. If you have feedback from me, that will be very welcome. Also critical feedback, because I'm also hoping to improve the manuscript. So again, we're very welcome to hear your points and thoughts on this. The title is currently From Co-Speech Actions to Co-Speech Gestures, Influences of Information Structure and Visibility on Cross-modal Synchronization. And before I start to go into details, I hope that I would like to elaborate a little bit on the term co-speech action versus co-speech gesture. So a co-speech action is something where you're moving while manipulating an object, perhaps, that might also be co-expressive or congruent with an ongoing corresponding utterance. So I hope this is clarified during the talk. So first, I would like to talk briefly about what we know about cross-modal synchronization, because this is kind of the subject that we have been working on. And there's a couple of really robust findings by now, that are many of which are concerned to prosodic prominence, or the role of prosodic prominence, which has shown to be a strong trigger for gestural synchronization. So it seems to be a good argument for an existing very, very tight cross-modal link that we find. Among other things, I'm just mentioning a few studies here. We have seen that high informativeness, in the sense of elements in the speech stream that are particularly novel or important, they tend to be, first of all, accented in speech. So they at least in many languages, like Germanic languages, Romance languages, they often co-occur with a prosodic accent, something a very prominent syllable. And that high prominent pitch accent also seems to attract co-speech gestures or initiate co-speech gesture production. So we know that. And also, interestingly, kind of shadowing what goes on in speech, we find, at least in the Germanic languages such as Dutch, that if gestures are repeated and that way they're kind of also information structurally given, they tend to be reduced in gesture space. And we also know that the same thing happens to pitch accents. So when pitch accents get repeated, because, or the underlying concept gets repeated in speech, they also tend to be reduced. So there is a very, very similar picture in both modalities. Maybe a bit more complicated are other aspects, though. So we do see synchronization, for example, when congruent semantic concepts are expressed with a gesture and said at the same time. That apparently, if there's a congruence in semantics across the modalities, that seems to trigger also cross-modal synchronization. So Kirsten Bergmann has shown this. It's a bit more complicated when it comes to information structure because there's different findings. So in a previous study that that we did, but which has some problems, methodological problems, I think we've seen, or we think we've seen some evidence that high informativeness or highly informative speech events seem to also attract co-occurring movements. While for Australian English, Kim and colleagues have seen that actually the opposite happened. So when they had utterances where speakers realized a narrow focus accent, then the co-occurring speech gesture was produced a lot earlier. So this is not really synchronization, but maybe the opposite. So for information structure, this seems to look a bit more complicated, the picture. We also know, however, from, I think, a very nice study by Breckenridge Church, that in fact co-speech gestures, like proper gestures where there's no manipulation of objects going on, but where there is just movement without any object manipulation, they tend to synchronize tighter with speech than less tight with speech than co-speech gestures proper. So gestures in themselves seem to also have this synchronization effect. Another thing that maybe isn't really proven, but where we have some indications that this might be the case, is that it depends on gesture type whether it is synchronized or not. So we have found, there is evidence that mutual visibility does increase the usage, first of all, of representational gestures, but it does not have an impact on the frequency of occurrence for beat gestures. So beat gestures seem to be like a different animal in a sense. And one thinks that this might have to do with the communicative relevance of co-speech gesturing, where beat gestures seem to be sort of, maybe the odd one out, or maybe the regular thing, I don't know, but they stay the same, independent of whether they play a role in communication. So this is something, this might be special and also maybe play a role for cross-modal synchronization, we think. Another indication that representational gestures might be different from beat gestures comes from Carol Kirchhoff's work, where she found that representational gestures, like iconic gestures, are still perceptually integrated with the speech stream, even if they're really out of sync and not in the vicinity of the co-occurring speech stream. So where do we go from there in terms of our study? There are a couple of research questions that we asked. I hope they make sense also to you. First of all, we wanted to look again whether this strong attractor of prosody or pitch accents to the co-occurring co-speech actions, is it activated only if the co-speech gestures or co-speech actions are of potential communicative relevance? In other words, does it survive when people do not see each other, or is it only present when people see each other? So that was maybe the main question that we had, but also we were wondering, and connected to that, whether or how hardwired this link between prosody and co-speech movements are. Because there's this idea out in the space that prosody and co-speech gesturing, that they're really linked maybe more on a grammatical level, that this synchronization is something that we cannot really strongly control, but that's something that just kind of happens automatically. So that would be in favor of a hardwired or low-level link between the two modalities. And also, if this is the case, it should be stable, independent of mutual visibility between people, between speakers. So in our study, we want to investigate two potential triggers for that might activate the cross-modal link. First of all, mutual visibility of hands, and second, information structure that also increases prosodic prominence or modifies prosodic prominence, because prosodic prominence has also been shown to be a strong cue for or attractor for cross-modal synchronization. So from that, we formulated two hypotheses. Our hypotheses are the speakers perform co-speech actions in tighter synchrony with their corresponding verbalizations if H1, interlocutors can see each other's hands, or H2, a verbal message is prosodically highlighted due to information structure of the ongoing utterance. So let's go to data or the study itself. So we performed a corpus analysis to test our hypotheses. And to do that, we looked at semi-spontaneous interactions between native speakers of Germans. We had 20 dyads. They were all friends. They were typically of a similar age. And they played a verbalized game of tic-tac-toe. That's a very, very simple game, I know that, but it has a couple of nice properties, which I will go into later. And the verbalized game, what does that mean? People play tic-tac-toe, and you can see in the setup here. So we had different visibility conditions. Sometimes people could see each other fully, sometimes only their hands, but not their faces. Sometimes they couldn't see each other at all. Verbalized means that while they were playing tic-tac-toe, they were also asked to verbalize what they were doing. So, which sometimes was necessary in the condition where they couldn't see each other, where they couldn't see the shared game board, and in other conditions it wasn't necessary, strictly necessary for the ongoing game. But they were always doing the same, like they were saying, okay, my next move will be on field number 3 or whatever. The fields were numbered of the game board. We then performed an acoustic analysis of the congruent, verbalized, and manual game moves, because people had to say which game field they would play. So that was always a number 1 to 9. Kind of a lexical affiliate, you could say. And we also looked at when they placed their game moves on the shared game board. And I talked already about the different visibility conditions. We had 4 visibility conditions, but in this study, I'm only looking at 2 levels of those. So either they had a mutual visibility of hands, and that's in the upper part represented here. So where they could either see everything or just the shared game board, but not their faces. And in the lower part here, we can, that's the illustration of the conditions where people could not see each other's hands, either by, because there was a curtain and not a transparent game board, or just a transparent, non-transparent game board, but no curtain. So those two factor levels were then analyzed further. And here we want to test our first hypothesis, whether the visibility of hands increases the cross-modal synchronization between prosody or utterances and co-speech actions. We also controlled information structure, and that's where the tic-tac-toe setting comes in. This is something that was not devised by us, but by Dwayne Watson and others quite a while ago, who also used a similar setup or a similar game to look at the influence of information structure on prosodic realizations in American English. We adapted that now to this multimodal study. But the tic-tac-toe setting has a couple of interesting properties, because you can easily manipulate or easily identify whether a game move is predictable or important, or both, or none. And why is that the case? So if you look at the figure 3, on the left-hand side of the game board, if the player places the blue square on the field number 5, he or she will make a move that is fairly unpredictable at the current stage of the game, because they could also move equally. It's equally probable to have had a move on field number 6, let's say, or maybe even to another field. While if you're in the next stage of the game, which is the figure on the right-hand side, where red places the move on the field number 7, that is, I would say, rather predictable, unless they're sleeping, but it's at the same time very important for the outcome of the game, because it prevents a winning move from the opponent. So those two types of game move we would have an informative level that would trigger a higher degree of prominence on the co-occurring utterance. So if I'm saying, okay, my next move is on 5, then I have a reason for accenting that, because it's unpredictable or important. In the game, we also had game moves that we called given, because they were entirely predictable and not important for the outcome of the game. Those were the first game moves which were predefined in our setup, but also the last game moves typically were ties, where nobody won, and that was the vast majority of the games that were played, because people weren't stupid, people paid attention. So we had a lot of those given moves, but of no communicative relevance, one could say. And those we hoped were also produced with a lack of prominence. So here our second hypothesis comes into play, where we say that informativeness increases cross-modal synchronization of prosody and co-speech actions. So let's now go to what we measured in our data. There's a couple of prosodic things that are kind of the typical stuff that you do when you look at phonetic analyses, when you do prosodic analyses. That's not very relevant, but I'll go over it briefly. So we looked at the duration, the average intonation of the verbalized game moves, the pitch range, their intensity, and the time of the maximal pitch excursion. So that would be when the accent on the, let's say, lexical affiliate or verbalized game move is reached, and that's depicted in the figure on the right-hand side. So where you see PA peak, that would be the time of the point where the accent reaches its maximal amplitude. We also looked at the onset of the verbalization of the realized game move. So basically the numbers 1 to 9, because that's when people said, okay, where they were placing their game move. That was the second anchor point that we looked at in our data for looking at cross-modal synchronization. And with respect to the manual action, we measured the time where the manual contact between the hand and the game board was performed. So it's not, let's say, the onset of the movement, because that was very, very difficult to determine. So we went for an objective point during the ongoing game when people actually realized their game move. And so we measured two different types of cross-modal delay. One was the delay between the pitch peak that was realized and the realization of the manual game move on the game board. That's what we call delay 1. And the second type of delay was between the word initialization or word onset and the realization of the manual game move. I hope that's clear, sufficiently clear, so we can move on. So we then performed a couple of statistical analyses. I just want to go briefly over that so that you know what we did. We calculated regression models that we optimized in a stepwise fashion. First, we calculated or reached those models that were maximal, containing the maximum number of interaction effects and predictors, but was still converged. And then we reduced them in a stepwise fashion with the R package build-mer or build-mer. When this analysis led us to interaction effects, we also conducted a post hoc analysis to look for contrasts. And we had two dependent variables. Those were those two cross-modal delay measures that I just talked about. So delay of game move to pitch accent and the delay of the game move to the word onset or word initialization. We also looked at a couple of acoustic correlates for prosodic prominence, but only to clarify that really prominence was also influenced by our manipulations of the recordings. We looked at a couple of fixed factors like information structure, obviously, and manual visibility, and random factors like speaker and the target move number. So as I already mentioned before, we looked at cross-modal synchronization. We performed a kind of a sanity check because we hoped that our game structure led to an effect of information structure on the realization of our prosodic prominence, but we couldn't be sure. So we had to make sure that this actually worked, that part of the setup. But we also wanted to see whether visibility or mutual visibility of the hands also had an independent effect on the realization of our prosodic structures in the verbalizations, because that also might influence our analyses and, of course, interpretations. Because if manual visibility also has an effect on prosody realizations, then we don't really know whether it's always the prosody that causes or influences cross-modal synchronization or something else, or really communicative relevance, right? So that was something that we needed to check. And that analysis yielded luckily, as expected, that information structure influenced also our prosodic realization. So unpredictable game moves were produced longer and had a larger pitch excursion, and important game moves or their verbalizations were also longer, had a larger pitch excursion and also a higher pitch. But so that was expected, that was nothing new, that was just replicating a previous work. But we also found that the visibility, the mutual visibility of the hands during the game move verbalizations also had an impact on the prosodic realization. So overall, people were quicker in the way they uttered, produced their verbalizations, and also were less expressive in their prosodic patterns. So this is something we had to take into account later on. So mutual visibility has an independent effect on prosody that's not concerned with cross-modal synchronization, but is still very interesting. So now I will go and look at what happens with respect to the cross-modal, what happens to the delay between the pitch accents and the co-speech movements or co-speech actions, depending on the level of visibility and information structure. And the first thing that we found was a bit annoying, but first it was annoying, then it was very interesting, because first I saw, okay, the residuals are not normally distributed, so I cannot do the models that I wanted to do. But then looking at the data distribution, that was really, really interesting. So what you see here in the density plot, there is a 0 on the right-hand side, and the 0 on the right-hand side, that's where the pitch accent is located, or the maximum excursion of the pitch. And we're talking about co-speech actions here. This is not co-speech gesturing. And the density plot now depicts the point in time where people actually where hands actually reach the game board while they're talking. So we see again, you see 2 peaks here, and one peak is almost at the same point where the pitch accents are. So the highest density, and that's just 18 milliseconds earlier than the corresponding pitch accent. So there's a very, very tight alignment between pitch accent peaks and people moving their hands or hitting hitting the game board, let's say. But there's another peak, and that's also an interesting peak, and we don't really know what that is. But you see that people distribute, obviously they have 2 targets when they do these, when they perform these co-speech actions. One is 200 milliseconds before a pitch peak, and one is almost co-occurring with a corresponding pitch peak. Still, people prefer this early movement. So if you look at the raw numbers, the early realization of the game movement of the co-speech action is still highly preferred. So like 1,000 versus 500 and a couple, basically. So this close alignment between the pitch peak and the corresponding action is still dispreferred, but it's possible. Like 1/3 or more than 1/3 of our moves look like that. So we think that this indicates that we actually have 2 attractors for cross-modal synchronization. One is definitely the pitch peak, and the other possibly something like the word onset, but we don't know exactly. So because of that, because of this bimodal distribution, we had to calculate generalized linear mixed models with a binary dependent variable for this delay 1. And what did this model reveal? Well, first of all, we do not find an effect of visibility. And this is really interesting, I thought, because it shows that, it doesn't really matter whether this alignment has a communicative relevance or not. So people do this alignment whether or not they see each other, which is, I think, interesting in itself. And we also saw that there was an interaction, meaning if a verbalization, or if a game move is unpredictable, but at the same time also important, so really, really relevant for the outcome of the game, and also unexpected. So it's kind of this gotcha, you know, I saw that you tried to trick me. I saw, I can't still prevent you from winning, haha. And you didn't see that coming. So those kind of game moves have a higher probability for this tight alignment between the pitch accent and the co-occurring manual action. But that was the only effect that we really found here. So, but still, I mean, this is obviously some effect of information structure here. If it really matters, then we come up with this bimodal synchronization, prominence-wise. Second, we also looked at this delay 2 between word onsets and co-speech actions and movements. So what happens there? This is a bit more complicated, but nevertheless very, very interesting. We have 2 effects here, or actually 3, but 2, which I will talk about more in depth. 2 is that, first of all, visibility has an effect here. Visibility, mutual visibility of hands makes the co-speech actions, co-speech movements being performed earlier in relation to the word onset. And significantly so, like more than 100 milliseconds, which is something. I mean, it's not non-negligible. It will certainly be noticeable in a perception study. So if you can see each other's hands, you will realize your game actions earlier as compared to when you cannot see each other's hands. This was at least the case for most participants. There was an interaction effect between participants, but I looked at the data and it's really the majority of participants who do that. Also, we see here an effect of information structure, namely in the sense that when a game move is completely irrelevant or has no communicative, let's say, well, is entirely predictable, and both players know what's going to happen, so to say, then those are also produced much earlier. And you see here in the graph, that would be the model predictions for the entirely predictable and unimportant game moves. Those are the ones that are very close to 0, and 0 means the word onset, the corresponding verbalization. So those are the lower bits here. So if you see something coming and both parties see something coming, then it's realized very, very early, close to the word onset. And at the same time, these will also be accompanied by very low prosodic prominence, which I think is relevant. Right, so what do we make of that? I'm already at the discussion, but I think I'm doing well with time. A couple of general findings, I think, are we replicate earlier work by Church that co-speech actions are temporally coupled with co-expressive verbalizations. We didn't tell people that they would have to speak while they were moving. It just happened. They did that. Still, I think that our task probably influenced our results because we forced people to do this. I mean, normally when you play tic-tac-toe, you would just, do the movements or draw something. You wouldn't speak about it. But yeah, so I think this is what one would have to see whether this also holds in more natural or spontaneous interactions. I think a very, very interesting finding that we didn't look for at all, it just came out, was this bimodal distributions of the cross-modal synchronization, where we had one peak closely aligned, co-occurring with the corresponding pitch accent, and another peak that was more realized towards the word onset of the co-occurring verbalization or lexical affiliate. This is really something that we didn't expect, and I think it's very, very interesting to see that. So I think this would point that maybe we have two anchors in the ongoing verbal speech, in the speech stream for cross-modal synchronization. Because that would also explain some of the story here. With respect to the synchronization between pitch accents and manual game moves or co-speech actions, we did find that mutual visibility did not influence cross-modal synchronization of pitch accents and moves. So apparently this tight link between prosodic realizations and co-speech movements seems to be hardwired in the sense that we don't control it depending on whether it has an impact on our listeners. So I think this is interesting. So I think it further strengthens this finding that we knew that prosodic prominence acts as a strong cross-modal anchor, but we do it independently of whether people have a benefit or communication benefit or not. Secondly, I think we find that this gesture lead effect, that the co-speech movement, or let's say also the co-speech gesture, tends to be earlier than the corresponding verbalization, seems to be possibly neutralized by high, very, very high prosodic prominence. So this is also something I find interesting. So if something is really, really, really made prominent, very, very prominent in the speech stream, then gestures, or let's say co-speech actions and prosody might actually co-occur, and not one leading or the other, which I also thought was very interesting. And what I'm making of this taken together is that the principal communicative function of those where really prosody and movement go together, maybe that's really the prototypical beat gesture, even though in our data, we didn't really look at gestures proper, but more at co-speech actions. But I think this might point what beat gestures are and why beat gestures are kind of a special thing and slightly different from, or very different from, representational gestures. So the second finding with respect to the synchronization between word onsets and moves or co-speech actions, here we did find an effect of mutual visibility. We did see that mutual visibility of hands makes these co-speech actions realized earlier. So this would confirm our first hypothesis that, and also, yeah, I think points out that this type of co-speech action is different from this beat gesture thing that we just saw. Also added by the further finding, yeah, or maybe not actually, we also saw here that if moves were very, very low in information structure or low in informativeness and lacking prosodic prominence, they were also realized much earlier, which confirms our second hypothesis. But for those low informativeness game moves, remember, for those we know that they also lack prosodic prominence. So the anchor of the pitch accent is weakened, and then the action is produced even earlier. So if I don't have the pitch accent as a strong anchor, then my co-speech action is realized even earlier. So I think there's two things taking place here. So taken together, I think these slightly earlier realizations of co-speech actions, if they are gestures, then they are probably more of the type of representational gestures. They're no longer strongly tied to the pitch accent, but they also help communication, and they're actually realized earlier when they serve a communicative function, when they benefit the listener. So they seem to be of this different category, and they are more aligned with word onsets, or at least it looks like that in our data. So to conclude, I think that our data at least points into the direction that we might have two cross-modal anchors in speech. The first anchor being the pitch accent, as we knew before, which serves as a strong cross-modal anchor and is clearly driven by prosodic prominence. So a very strong prosodic prominence strengthened this link. Probably this tight cross-modal synchronization in that case also serves as prosodic highlighting, namely, this probably are beat gestures. Also, because this connection is independent of mutual visibility, it seems to be a very low-level thing that we don't, and we do not make it, produce it depending on whether or not the gesture is seen or this action is seen by a listener. The second anchor we propose could be word onsets, and they might serve as the anchors that are in line with communicative needs by the interlocutor, by the listeners. They seem to be meant, they occur that they are meant to be seen. They tend to strengthen the gesture lead effect for an early disambiguation of the message, which makes a lot of sense, especially when you're semantically congruent. So already reveals what you're going to say, then this increases the overall robustness of the communication, leads to an early disambiguation of the message. And I would claim that this is more like a representational gesture. So our findings are very much in line with suggestions by Stephanie Schetter-Hufnagel and Wren, namely that beats and representational gestures might actually differ with respect to their synchronization with the speech stream. And I think that what we don't really know is if these two anchors are there. It looks in our data as if they compete sometimes, but how they compete and whether they compete, I think this is a very open question. And that's all from my side for today. Thank you.